Welcome to Getting to Know Google SecOps. I'm John Stoner, and today we're going to introduce a string function that takes base 64 data and decodes it in search and YARA-L rules. Now, we don't often see base 64 data sitting all by itself within a UDM field, so this command is often applied to placeholder variables or nested with other regex functions. In our last video, we discussed the re.capture function and how we are going to build on this concept and then use the base 64 decode function to uncover what lies beneath the encoding. Base 64 can often be used to obfuscate code, so having a function built into Google SecOps to work with this data can streamline detection and response. The function is very straightforward, just pass the encoded string to the function, so really the question becomes, do we read it in directly from a regex function that captured the base 64 string, or read a placeholder variable where the base 64 is already being held? Let's take a look at it in action. Our rule builds on the example that we had when we looked at re.capture. That is, we're looking for encoded PowerShell strings within the target process command line. Here are our detections when using the re.capture function. Now, at this point, we could copy and paste our string into a decoder, but that's an extra step and requires us to pivot away. It also doesn't allow us to work at scale with multiple encoded PowerShell events. But with the strings base 64 decode function, we can add this logic into our search or rule, and it just happens. In our first example, we have the encoded string already captured and written to the placeholder variable encoded value. To create a placeholder variable with the decoded value, we could copy our logic from the encoded value that includes the capture function and then encapsulate that with our strings base 64 decode function. Now we have a placeholder variable for both that can be used in the events section of a rule, or we can use those placeholder variables and statements in the outcome section to format these fields in our detections. However, if we just need to output this decoded value in our detection, we don't even need to put this nested set of functions in our events section. We could just create our outcome variable and use our nested functions to output it there and be done. Either way, when we test our rule, we can see that we have the decoded PowerShell, and we can see the multiple detections where we now have actionable information to dig into and assess if the encoded PowerShell events are suspicious or not. With all of these functions, there is some variability how they can be deployed, so these are just a few ways to use these functions. As you can see, strings.base64_decode is very straightforward to use and provides analysts with a method to gain visibility into base 64 encoded data without having to copy and paste out to CyberChef or some other system. However, because base 64 is often not the only value within a field, a combination of regex functions and placeholder variables are often used to work with this data. As you saw from our demo, the formatting of the base 64 may make it a bit tricky to work with if we are performing additional analysis on it. With that in mind, next time we're going to look at one additional regex function, re.replace, and we'll show you how you can tidy up your decoded base 64 to work with lists and other logic. If you want to learn more about Google SecOps, check out my blog series called New to Google SecOps for more handy tips. We have a number of community YARA-L detections at our GitHub site and are continually adding more. And don't forget to engage the security community at secopscommunity.com.